So hi guys, welcome to my channel. Today I'm going to explain this question which is of GFG POTD. Find the length of loop. So let's see what question is trying to say and how to approach this problem. So given the head of a linked list, determine whether the list contains a loop. If a loop is present, return the number of nodes in the loop, otherwise return 0. And C is the position of the node which is next pointer of the last node. Basically C is the pointer, like this node is pointing to the where the last node is pointing to the node. If C is 0, then there is no loop. Okay, so let's see with an example. This is the example. Okay, so we are given this node and we have to find that if there is a cycle in this linked list, so we have to return the how many nodes are present involved in the cycle. So let's say we can clearly see that there is a cycle in this linked list, and if there is a cycle in this linked list, then we have to return how many nodes are involved in that cycle. So this is okay, let me change this. So this 1 2 3 4 5 6 7, so 7 nodes are involved in the cycle, so the answer is 7. You can see that output is 7. So now first step is we have to move forward to approach this question step by step though. So our first step is detecting cycle that if cycle is present in the linked list or not. Then the second step is to find the starting point of cycle. And if we reach at the starting point of cycle, then we know that here this point is the starting point, and we can count that what are the nodes that are involved in this cycle, so it will be easy. Now third thing is count the nodes. So let's see one by one how we can approach this problem. So there is a very famous algorithm to find the cycle in this linked list, which is Floyd cycle detection. Floyd's cycle detection. So it is basically the concept of slow and fast pointer. So let's see how we can detect that there is a cycle or not by using slow and fast pointer. So let's say our current pointer slow is standing here. So let's directly mark it with S and mark it with F, fast. So now what we can do is we have to move the slow pointer one step, and fast pointer we have to move the slow pointer once and fast pointer 2 steps ahead. So let's move it. So slow is here. Okay, slow is here, fast is also here. Now slow will move to this, fast will move to this, 2 pointers ahead. Now slow will move to this and fast will move to this. Now again slow will move to this, fast will move to this. Now slow will be here, fast will be here. Again slow will be here, fast will be here. Again slow will be here, fast will be here. Again slow will be here and fast will be here. If at any point slow and fast pointer meets, then there is a cycle. It's basically the condition of Floyd cycle algorithm. Like if slow and fast pointer meets, then there must be a cycle present in the linked list. So we will mark it as like here the cycle is present, so we have detected that there is a cycle. Now if there is not a cycle, then automatically slow or fast, any of the 2 pointers will come to the null. Like if there will be null, no loops, no nodes here, then either the slow will come to null or fast will come to null, so we don't have to worry about this. Now the second step is how to find the starting point of the cycle. So in this Floyd cycle detection only, take any of the two pointers, like we have got like we get that on 90, on pointer 90, the two pointers are meeting. Now put any of the pointer at the starting, like I'll be putting slow here, and okay, fast will be there only, slow here. Now start moving one pointer ahead, both the pointers. So slow will be here, fast will be here. Now again slow will be here, fast will be here. Again slow will be here, fast will be here. Now we got the starting point of the loop. So to find the starting point of the, again I'm repeating, at what point, at whatever point the slow and fast pointer will meet, like if slow and fast pointer will meet, then we are getting the cycle. Now what we have to do, take any of the pointer and move to the start, and start moving slow and fast one by one, and at whatever point they will meet, that will be the starting point of the loop. So to find the starting point of the cycle, so we got it. Now start is standing here, and slow is standing here, fast is standing here. Now we have to just one thing, this is also done. Now we can initialize count is equals to 0, or let's say count initialize it as 1, and move slow to this. Why I'm doing this? Now move slow to this until and unless slow again comes to fast. Why we are doing? To maintain the count and to store the elements, how many elements are present in the count. Let's say count is equals to 1, and once move the slow is equals to slow next, then slow will be pointing here. Now take one condition, that while slow is not equal to fast, move slow and increase the counter one by one. Then slow will come here, count will become 2. Slow will come here, count will become 3. Slow will come here, count will become 4. Slow will come here, count will become 5. Slow will come here, count will become 6. And finally slow and fast again meet, then count has become 7. So with these 3 steps we have solved the problem, and we got the desired like what are the nodes that are involved in cycle. No, 7 nodes are involved. So let's directly jump into the code. So whatever I am doing here, like I have initialized the slow pointer at the head, fast pointer at the head. So just like same I am doing here, slow pointer at the head, slow pointer at the head, fast pointer at the head. Okay, so while fast is not equal to null and fast next is not equal to null, why I am moving fast? Because it is obvious that fast is moving much ahead of slow. So if there is no cycle, then fast will be the first one to reach the end of the loop or end of the linked list. So we have I have put the condition sorry, that if fast is not equal to null and fast next is not equal to null, till then you have to run the loop. So slow is equal to slow next, one step ahead, and fast is equals to fast next, one step and two step. Now we are doing this to detect cycle. This is our step 1. Now if at any point slow double equal to fast means slow equal to fast, then we have okay, I have initialized a variable, bool variable cycle, so that to know that if there is a cycle or not. If slow double equal to fast means there is a cycle, so mark cycle it as true. And then now our second step is to find the starting point of the cycle. So I have moved, let's say at this point we have got to know that there is a cycle, so I have moved slow to the first to know the starting point of the cycle. So cycle is true. If cycle is false, then directly return 0. We got to know, we are instructed here is, if C is 0, then there is no loop, means directly return false. There is no loop, otherwise return 0. Okay, so we have returned 0. But what if cycle is true? Then I have moved slow to the head. Just I have told slow to the head. And now while slow is not equal to fast, move slow one step ahead, fast one step ahead. Like here I'm doing, I have moved fast one step ahead, slow one step ahead, and finally we meet slow and fast here. at the starting point of the node. So this is step 2. Step 2, to detect the starting of cycle. Now after detecting the cycle, like starting point of the cycle, I have moved slow to one step ahead and make the count is equals to 1. Slow one step ahead and make the count is equals to 1. Now while slow is not equal to fast, move the slow pointer once and increase the counter. Same here, move the slow pointer once and increase the counter. So I can directly return count here because I have already checked it. So return count finally, because if there is no cycle then it would have already returned 0 here, so there is no need to. So next is count the step 3. Count the nodes involved in cycle. Now slow one step ahead and count plus plus. So as I have told that, slow one step ahead and one step ahead and count plus plus, then this, while reaching this, and we will be storing it our answer in the count variable. And this is how we have solved this problem. Let's run and submit it. So I hope this will look easy for you because I have broken the approach of this problem in 3 steps. So thank you for watching this video. That is it for the day. Thank you.